Welcome to Knowledge Graphs, moving beyond RQL RDF. My name is Kurt Cagle, and I want to thank you for joining me this afternoon. A bit of a timeline, and note that these dates are only approximate. RDF, the Resource Description Framework, was created in 2000 by Sir Tim Berners-Lee and others, pursuing an idea that emerged as he was developing HTML. With that language, he had observed that hyperlinks, which connected a phrase or image in one document with a document elsewhere on the web, could be generalized to the idea of one concept or resource having a relationship with another concept in a conceptual space. This web of ideas, which he would christen the Semantic Web shortly thereafter, would end up driving the graph revolution of the 2010s and beyond. Originally, he used XML as the default language for this web, but over time, he realized that XML wasn't ideal for the task, even as he and others worked out a logical formalism language called the Web Ontology Language, or OWL. By 2007, SHACL, an RDF query language, was produced to querying sets of assertions using a new language called the terse RDF language, or Turtle, formally released in 2014. SHACL 1.1 was released about the same time, and it's worth understanding that Turtle and SHACL have only just gotten started. This is very important as it effectively marked the end of the RKO RDF era. Turtle tends to get a lot of short shrift, first from ontologists who grew up with OWL, RDF XML, N3 notation, and Protege, and from those newer to graph technologies who felt RDF XML and OWL were too complex or too dissimilar from the way that they were normally working with languages like JavaScript and Python. However, Turtle, as a language, has a great deal to recommend it. It is a much terser language than RDF XML. Certainly, it's terser than N3, and arguably is terser than JSON when namespaces are taken into account. Please see JSON-LD. While OWL was built on XML, RDF XML can be very verbose and far from intuitive. Turtle is actually a surprisingly good language for expressing triples. It makes a good language additionally for prototyping or modeling objects. What's more, Turtle and SHACL are largely complementary because they essentially emerged in tandem. As SHACL continues to evolve, so too does the expressiveness of Turtle. Indeed, I contend that part of the reason the Turtle isn't used more widely is because it is a very young language, younger than JSON, and developed to express a very different need. Indeed, the primary limitations of Turtle as a language are simple. Turtle isn't JSON. We'll come back to this. It's worth dividing up the evolution of RDF into three distinct eras. The first, the RKO RDF era, was largely dominated by OWL, utilized N3 for ingestion, a not very common format, and was built primarily for inferencing, a glorified word that means that it is possible to express new assertions by using logical operations on the existing graph or triples, then adding these back in as virtual triples. Serialization was primarily accomplished via a fairly ugly XML representation. It appealed to academics, but was not very attractive to the bulk of programmers out there. The Meso RDF era, on the other hand, began with SHACL 1.0, released in 2007, but took both the emergence of Turtle around 2012 and the beefing up of SHACL in 2013 to really take off. This was RDF's nuclear winter, where interest in the semantic web as an idea almost died, even as significant new developments, the emergence of turtles, not mammals, were taking place. SHACL 1.1 brought with it some significantly needed improvements, though was still not quite sufficient. The SHACL update facility was also introduced, replacing virtualized triples with formally persistent ones, and the notion that you could query in a federated manner was introduced, although again not fully fleshed out, at around the same time. Finally, we began to see the first upticks in the use of JSON as representations of triples, especially in corporate environments, with JSON-LD linked data. It could be argued that JSON-LD is probably in fact, an evolutionary dead end, but it is signaled that the two communities were talking with one another. I believe we are in the beginning of the neo-RDF era. There are a whole host of new developments in the last few years that are beginning to coalesce, and that will likely be formalized within the next couple of years. This is not necessarily all where RDF is going, but it is what is most visible right now. I wish to cover each of these individually. The RDF world tends to spit out big, scary words. One of these is reification. A reification is a statement that describes another statement. For instance, let's say that you have a statement that specifies a relationship, a has-route-to relationship, between two airports in Seattle and San Francisco, respectively. This description describes a route, and that route can have multiple properties, such as distance and which airlines fly that particular route. Labeled property graphs, otherwise known as LPGs, can describe the first relationship, but sputters on the second. With RDF-Star, first proposed in 2017, and SHACL, a more compact notation for reification was proposed for both Turtle and SHACL. This new notation makes a great number of operations, including queries, updates, and versioning at the property level, much easier, and goes a long way in making RDF graphs compatible with property graphs. A second area where some exciting development is happening is in the increasing sophistication of property path languages, something familiar to users of both OpenCipher and Gremlin. With new ways of describing property graphs as first-class objects and providing ways of specifying wildcards and variable bounds, such a language could radically empower SHACL to combine both inferencing and graph analytics operations into a single unified language. While there are several potential candidates for such a language, SHACL property paths look to be the most promising areas yet. This will be covered more when I talk about SHACL. SHACL, the shape constraint language, like most RDF technologies, was formulated in reaction to the emergence of Turtle as the new face of RDF. Going through several iterations, it was finally approved in 2017. SHACL, ironically, is changing the dialogue about data modeling with RDF away from the OWL-specific sets of rules and formalisms towards a format that is more familiar to data modelers, application developers, and data scientists. In many respects, it is providing key in the integration of RDF with GraphQL as well. There is an active community now looking towards a SHACL 2.0 implementation, building off of the previous implementation's weaknesses. Already there are implementations pushing these boundaries by incorporating more sophisticated property paths, establishing functions, arrays, sets, and dictionaries as first-class objects, fixing significant problems with lists and how they are managed in SHACL, utilization of JavaScript-like capabilities such as MapReduce type operators, Lambdas or arrow functions, and template literals, and utilizing SHACL to make JSON construction much easier. GraphQL is a good idea. While it is not part of the W3C stack it was originally developed by Facebook, it should be because it works very well with what RDF was intended to be. GraphQL has limitations. Reification is almost impossible to manage. The JSON data model is just not as robust at handling things RDF does well, including inheritance. And its hierarchical structure is at odds with the potential cyclic nature of graphs. But it is useful language for making RDF stores look like JSON stores from the outside world. SHACL is playing a big part of that, and almost every GraphQL bridge currently in production uses SHACL on the back end. With some changes to SHACL to make JSON constructible directly from graphs, this could mark the merger point of these two query language technologies. Redo. The 2013 specification is a good start, but as implementations have been built, holes have become obvious. This will happen soon, probably within the next 2 years. Finally, it's worth recognizing that machine learning and graph technologies are on a collision course, and it is likely that the next innovations will be the integration of these two, for everything from discoverability to better classifiers and more robust machine learning models. Thank you for listening. Please feel free to drop me an email or contact me on LinkedIn if you have any questions. Thank you.